Okay, so I'll be demonstrating how to do simple fuzzing using Go. So let's first, so we have a folder here, and we're just going to make a simple Go module. So go mod init fuzz. Okay, so they just create a Go module. So now let's add a file. We'll call it main.go. And then this is going to be a very simple program. So so we're just going to take a simple reverse program. All it does is takes in an input string. It does some reverse, so it takes all the bytes. It will go through a for loop, reverse each single, reverse the first index with the last index, and it will go towards the middle, and then reversing each string, and then it will return the reverse string. And then we'll also do a double reverse, so this should give us the original string. So let's try running this using go run. Okay, so you can see this is the original string, and this is the reverse string, and then we get the correct reverse of the string, which is the original string. Okay, so this is working. Now we're going to create a test case. So we'll just write a simple test case. We'll call it like reverse test.go, and then this will be like a very simple test program. So something like this. So we have a test result that takes in a input, a series of strings, and then we also have the reverse of those strings, and then it just tests each of them. And if it's not the reverse of our string, then we just give it an error. So to run this, we'll just do go test. Okay, so we see that everything passes okay. Okay, so now we're going to add the fuzz test. So we're going to replace this with a fuzz function. So instead of our test reverse, we'll have a fuzz reverse. So essentially this takes in from this testing module, this takes in a fuzzer. So this is a fuzz test, and then within the fuzz test you also have a normal test. So we'll pass in a normal test within this test. So the Go program knows like what inputs to fuzz. So also to start with, we also have to add a seed corpus. So this is essentially like the base test case for Go to run normally. And then yeah, the fuzz test case is the same as before. So one thing to note is that when we're fuzzing test cases, we don't know like what the final output of the test will be. So as before, in the last example of the test case, we had the reverse of hello world, reverse of this number. But since we'll be adding some fuzzing to this, we will not know what the reverse of the string is, which is why what we can do is we can check for certain properties. So what we'll be checking is to see if the original is equal to the double reverse, right? So if you reverse a string and then reverse it back again, you should get the original. And then we'll also check to see if the string is a UTF-8 string or not. So if we don't get a string back after reversing, then this is not a correct reverse. So these are the two properties we'll focus on currently. Okay, so now let's try running just a simple Go test again. So okay, so we need the UTF Unicode 8 because we're checking to see if it's UTF-8 or not. Okay, so let's try running it again. Go test. Okay, so we can see that everything's passing. This is because right now it's just using the seed corpus that has been given to it. So it's just testing hello world, empty string, and then this number, and then it passes like it normally did. Okay, so now we're going to add fuzzing to it. So the way you enable it is you do go test and you do dash fuzz equals capital F U Z Z. So this will add fuzzing to this test. Okay, so we can see that it actually failed, and it failed on this reverse UTF string. So when it tried to reverse the string, it got this string that is not a valid UTF, UTF-8 string. One way we can check to see what was given in which it failed is we can go to this new directory that was created. It's called test data, and then from here we can see it ran the go test with this like special character string that it randomly chose to use. So you can take a time to figure out like why this failed and how can we solve it in here. Okay, so the problem is that we're using a byte, and this will only be true for instance, English words or English letters taken as a byte. However, if it's any special character of other languages, then we cannot represent them with just the normal byte. So what we have to do is we have to use a Go ruin. So ruin are basically int 32 representation of any character in any languages. So very simple fix is that we just replace this byte with ruins. So now we're using ruins instead of bytes to represent each characters. Okay, so now let's run go test. So if you just do go test, it will run the original seed corpus along with the created automatically generated seed as well. So we'll try running with this, and then we'll check to see if they all pass. So let's do go test, and we can see it all passed. So another way that we can like make sure that the other tests are running. So if you just go back to the old code, right? Go test. So you can see it failed on the invalid input. So we know that it's using this input that it generated, fuzzed input. So let's go back to the original, and then with go test with our new solution, everything's passing. Okay, so now let's try running fuzz again. So go test dash fuzz equals fuzz. Okay, so now we actually have another problem. So we can see here that the new test that was given is this slice of a string, and we get this unique character, and it's failing because of and this is failing right here because this is it's saying that before, let's see, where is it? Yeah, so right here this is before this, after that. So it's failing on this check, which basically says like, okay, the new string is not the new double reverse of that string, is not the original string. So it's failing right here because it's saying this was initially, and then we reversed it, and then we reversed it back again, and then we got this. So this is because if you look at the test code, so this is a string that was given. The reason why this is failing is because Go will take this as an input, and then it will automatically try to get the UTF-8, like it will take this as a ruin, and it will try to get the UTF-8 of this string, which would become a special character, which is this special character, for instance, right now. What we have to do is we essentially have to do like a status check. So we cannot, we shouldn't be taking inputs that are special characters, right? Like for instance /xfl. So a simple solution to this would be to just change our rune program again. So one way also we can check to see that this is incorrect is if we do some print statements around our next to our. So let's do a print statement right here, and then if you run the go test, we can see that these are the special characters that were given to us, right? So input this, that's the rune. So we can see that for this input, the rune ends up being like this, right? And then, yeah. So this is how the Go treats these character as, like they take the whole character string slice and then it turns it into this character. So we don't want Go to do this. So the way we fix it is we have to do some error checking in this to make sure our input is valid. So a simple error checking here would be to replace this with a UTF-8 checker. And then we check to see if it's a valid string, if the input is a valid string. If it's not, then we just give it an error. If it is, then we continue our program like we normally did. And for this, we would need a few more imports. So we need the errors, we need the Unicode, and then the FMT. Okay, and then we also have to do some error checking right here in our main function, because now we're reverse can return error. So we just have a little reverse error or a double error, and then we just print those errors out here. We also need to change our reverse test as well. So let's add within our test case. So let's add a simple error checking within the fuzzes. So we'll just go here. We'll replace this function with a function that takes in the output and also checks to see if it's an error or not. So if the reverse throws an error, then we just return. We don't continue on the program, right? So, but if there is no error, then we continue to double reverse. If there's no error there, then we continue again. Okay, so now let's try running go test. And now we can see that everything's passing. So everything right now is being tested on the seed corpus, as well as these two test cases that failed previously. So now we can continue on running go test with Fuzz. And then we're going to do another thing. So what happens is when you just do go test Fuzz, Go will continuously test our program with new inputs until it encounters failure. So the way we kind of set a limit to this is we just do dash fuzz time, and then we just do 30 seconds to fuzz for only 30 seconds. And then now we'll start our test. So you can see here, Go has started running the tests. My PC is, or my CPU is Intel Core i9 14th generation. So it has 32 cores. So it basically made one worker for each core, and it's continuously running, executing test cases for each of those on each of cores. So it will continue to run for 30 seconds, and then yeah, it will stop. We can see that each second it executed about 1,533,000 test cases. So in total, within the 30 seconds, it tested for 45 million different fuzzed inputs. And then everything passed. So great. Hope you guys enjoyed the video. Thanks for watching.